All right, welcome everyone. Apologies about the extra disasterness of the earlier part of the week. This will start covering some of the core fundamentals of how Matlab operates. Since we kind of missed a couple of the key parameters, I know Dr. K does a really good intro in his particular video, so hopefully you guys got a chance to actually make use of that data. I like the command window and the sum total of the workspace laid out kind of a what I guess what is now closer to the default workspace. Used to be we had to do a lot more configuring, but yeah, there's a lot. So the default layout is effectively this, where we have our current folder. Even more so in Matlab rather than in some of our other directories and various places. Matlab, this is very, very important to manage directories. Directory meaning the specific file you're in. If all of the files that you have to reference are not in the same directory, Matlab does not deal well with that. So you want to make sure all of your files are not saved to users and temp or something like that. You want to save it to a specific folder for Matlab, typically somewhere under your documents, because that way you can find things. So I've done a lot of different projects in a lot of different areas. So there are under the directory, there is going to be, in this case, it's users and Kyle. The Matlab is going to be the primary folder that I'm going to be referencing. So I'm going to select Matlab, double click that, and actually I'm going to go up one. I'm going to right click, and I'm going to say, okay, so we are already included in path right here. There will be a command if you haven't already. You want to make a Matlab folder. If you don't have one, you add to path from here if it's not, because the path and directory are terms that I will use interchangeably. It's an old habit related thing. So here we are. We have a lot of different kinds of processes, and I have a zillion more Matlab programs in another folder that I think is not in this particular hard drive. So that would be an instance of me needing to go track that down all the way back up to the hard drive level. So I would go up to find the other hard drive. But in this case, I'll stick to Matlab. So Matlab, you want to include folders and subfolders, because if you don't, you'll just get the top line folders. So I'll remove it from path, and then I'll show you what that looks like. Add to path, selected folders and subfolders, and then see now all of this is included. And we'll learn about other things. You can effectively create something resembling libraries. There's some function files, and we'll deal with all kinds of things like that. But we got to get familiar with the interface and the fundamentals and functions first. So that's where we're going to put our emphasis. So I'm going to leave it here in this, and I'm going to come back to this. So sometimes you need a wide window, sometimes you don't, but the key for operating in Matlab, you can enter commands. These commands are going to be different than Arduino, but I am going to encourage you guys to start using scripts immediately. So this is like doing a sketch in Arduino. There's a few sort of differences. There's a few kind of commands that you'll want to get familiar with. One of the first things that you guys are going to do overall is going back to the home tab. So the editor is going to be where you're going to spend a fair bit of time. MATLAB makes it a lot easier to do running sections and doing section breaks to make sure your code has the right output. You guys are going to work on some projects that are based on some MATLAB live scripts, if memory serves correctly, and that will help to make all of this stuff work. So MATLAB is a really immensely useful tool. There are additional apps and things. We're not going to worry about those for right now. There are so many ways to plot data in MATLAB. It's truly ridiculous. 3D contour, mesh, surface plots, those are some of the most useful for a lot of reasons, just because they're a lot more easy to do in MATLAB and have control over image processing and complex data sets than other types of lessons. So there's a lot to kind of understand about this, but from the home, you're going to start a new script. There are ways that you can import data to MATLAB from especially Excel files. There's a lot of stuff that you can do with that. You can have it check the code and verify that it will compile, looking for, and nowadays it'll actually look for some coding inefficiencies and things. That level of analysis used to have to be done by hand, so major improvements to this process. So you want to make sure that your workspace is always showing that your I like the panel tiles and the tool strip. You can dock and undock these windows and some of those things, so I'm sure you guys have seen some of it. But in case you didn't follow the link, you want to start with this Learn MATLAB tab. So it'll come up in MATLAB. You're going to log in with your login info, and you're going to go into the on-ramp, and the on-ramp is going to kind of give you some fundamentals. There's additional resources. I highly recommend that you guys go through the MATLAB. The MATLAB on-ramp is required because you have to submit a certificate that you've actually done it. This is something that I used to have on my old account and don't have on my new account. Anyway, this is what it looks like. So it does have videos and all sorts of things, gives you an overview and talks about commands. And these are really core to understanding how some of this stuff works. There's some problem solving that they have you do that allows for things. So just for the purposes of being able to see some of what goes on, let's do array indexing and modification so that you guys can see an example. So it'll bring up a MATLAB environment. And it will show videos and all of those sorts of things, which tend to be helpful. So they'll give some instruction.
Every variable in MATLAB is an array. So to program in MATLAB, you'll need to know how to work with arrays. Referring to elements in an array is the first.
So you guys can go through and run through this. It's really important to understand indexing, and their notes here are that the index is a series of either positions, so third element, meaning the third item along a vector X. If it's a row and column, it'll still allow you to kind of get that information, but it'll look for a row column assignment. So A 2, 3 or something like that is a really important designation. You can also grab all of the either rows or columns or both by using a colon. So not a semicolon, but a colon. And in MATLAB speak, you'll see the way that the actual environment operates and the way that this works. This is set up fundamentally as what's called a Matlab live script. That's why it says live editor here. This allows for feedback to be given and specific output to be run. I would love to explain to you just how great this particular task is, but they load a data file. So you do that using the command. You'll notice, and data is in MATLAB speak, this loads the file type, data file. So data file has to be loaded into the same directory. In this case, they're handling that on the back end, so you don't see all of it. I like to have all of my other tools available so that I can see whether or not the file's there the way I think it is. The typing the name of the variable outputs the data, and it outputs the size. So this is step one, is verifying that this has run. In subsequent runs, so if I run this code right now, I get the data. Now, especially in the live view, there's so many cool features. I could talk for a long time about the way that this works and why. I will spare you some of that, but not all of it. So 7 by 4, 7 rows, 4 columns. There are numbers and a not a number that comes back. That will become relevant later, but we're going to leave that for now. So task 1, you can extract values from an array using row column indexing. So this syntax gives you the 5th and 7th row. So what they need you to do is create a variable x. So x, we just created it, equal. So I'm going to use spaces to make sure. It'll give you error warnings and say this might be invalid MATLAB syntax. You'll see in a second what this is. We're not defining variable types always in the same way that we are elsewhere, because we're not specifying, hey, this is an integer. MATLAB is a little bit better about the default handling of data types inside of variables. This is a really important thing to understand. This is part of the reason why we didn't start you guys in MATLAB to learn programming. We started you in Arduino, where we can kind of put you all in the kid gloves and get you in the arena and learning some things, ideally without anybody needing new dental work. Well, now we're into the part of the semester where you get the new dental work as part of the plan. So we create a variable x that contains the value in the 6th row and 3rd column. So we need to pull it out of data, and we need to specify, gosh, these helps are ridiculous, absolutely ridiculous. I wish you guys understood. 6th row, 3rd column. Now, of the variable data. Now, we want to output this. If we did not, we would do what's called in MATLAB a suppress output, which is the semicolon you're used to. If you do that, then it doesn't print out anything, and this is what it'll show. So you can also say just run a section, since we already ran the first part, and nothing happens. And you can run the whole thing, and it outputs here, and nothing happens. Because this is suppressed, so we unsuppress this output, and it'll give us what x is. X is in the 6th row, 3rd column, 9.0698. Great, excellent. So we're done with task 1. And then it can grade along the way and do some cool stuff. So next, the reason why this is an immensely useful way to get through some of the projects is it's very helpful to see how data is handled in MATLAB and why some of the command structures are different. So there's some stuff that's already sort of loaded into the compiler in the back end of MATLAB to simplify life, so that you can, in MATLAB, sort of more or less just start coding instead of includes and libraries and setups and variable types and all the other gibberish that we've had to do for Arduino. Even Arduino really does a lot of that setup compared to original C coding or even true core C++ coding. So we'll leave that aside for now. But there's a lot of core aspects of what we're going to do. And they give you some really clear indicators of this is what that looks like. So you can use the keyword end as either a row or column index reference in order to get to the last element. If you go, I don't remember how big that is, or the more practical use scenario here is we're going to store something to a variable named y. So we're going to say y equals. And we're going to say we're going to take the value in this case, the last row in the third column. What if you're pulling in data sets that you don't know how big they are? Then you're going to need to know, well, I just need the last value in this, in this case, the last row and the third column. So we do end 3 as our reference. We're not going to suppress the output there. Data is the array that we're pulling this information from. Rows, columns, y equals. So I can run this section and test and make sure that it works before I go to submit it. They'll allow you to see solution, but you don't get credit for it. I don't seem to recall. So anyway, there's some things along the way there that can help. But I'm showing you guys how to sort of use some new things and things you haven't learned yet in order to get through this particular first task for this week. So there's a lot of core fundamentals to operating Matlab that's a lot different from Arduino. It's simpler in many ways, but also more complex because it's really focused on what Dr. K explained was the name came from Matrix Laboratories. So this is all stuff that kind of came from the mind of Cleve Moeller and a couple of other folks, who is a person that I've actually met in person. So he gave the commencement speech for my engineering class. So you could say Matlab is sort of a thing to me. Anyway, this gives us the last row, third column. So this is helpful shorthand, especially if you're processing different lengths of things. We're going to learn later how to use some other functions to calculate lengths and sizes and extract specific details out of that. So even some of those functions give you back row column format data, but again, I'm getting ahead of myself. So 5.3002, last row, third column, correct. So we can submit that. Task 3. So you have to click to next task in order to get the submit button. So you do have to walk through the steps sequentially again. That's why I wanted to pull an example from this as one of the key elements here. So you can use arithmetic with a keyword end as well. So processes, the way that these work is if we create a variable z, so we're going to say z equals, and we're going to say it needs to contain the value in the second to last row. So z equals data, and normally you would have to encapsulate the math in its own parentheses if this were another kind of program. Matlab is able to contain between the commas some certain operations. So data end -1. So second to last row, third column. This is just a simple example of addressing. You don't have to include the space in here. I tend to just Sometimes, some of the times I don't, depends on how I'm feeling that day. So I can run this section to verify that it pulls the second to last row, third column. So we get our information that we need here. So I know it's pulling the data that we're looking for because we're looking for the second to last row, third column of data. So the further practice is not something that you have to include from what I remember, but it gives you a chance to extend the concept that you've included. So you need to create, in this case, yeah, we're going to create a variable that's going to be an index variable. So we're going to say idx to create the variable equals store the value to the variable with the value 8. Now, I don't want that output, so I'm going to suppress it, and I'm going to go to the next line, and I'm going to, using one index, try extracting the 8th element of data. So for this, we can use a variable that has some value. So the 8th value out of data is going to be data and then the address. So you can use a few things and even suggests IDX for the index variable. Again, it's essentially cheating. This is utterly ridiculous. And what that's going to do is give us the 8th element. So let's count and verify that this is in fact what we're looking for. So 1, 2, 3, 4, 5, 6, 7, 8. Row, column, format. So 1, 2, 3, 4, 5, 6, 7, 8. And so on. What this does is gives us the 8th element in a linear form, and that's what we can do. So we can check and validate, but I know that's correct because that's what it's looking for. There's a lot of useful applications of all of these different techniques. So I'm going to step out of this and look at a couple of the other. Yes, I know that changes may not be saved on that. All right. So what I wanted to do is show you, this is, okay, so this is extracting. So I guess we'll array indexing and modification. We'll finish this particular module just so that you can see a couple other components, because that's really one of the core things that you need to start with in terms of learning lessons about MATLAB. So it'll take a few minutes. I forgot that this is still within the same module. So completing a module will be helpful. It'll at least give us an idea of how these things work. So, all right. So running this section, we get our data block output. So we know data is loaded into the system. We know what the data is. It even shows you the format hovering over. These live scripts are so much better. You guys don't even know. So now we need a column vector named density. Typically, this is something that we're going to need to be very, very careful assigning. So there's a couple of reasons why. So we're going to learn using this colon operator. So we're going to create a column vector named density that contains all of the elements from the second column of the matrix named data. So out of data, we want all of the rows for the second column. So all elements in the second column is colon 2. So second column, all rows. If we run this, we get out of this set, the second column, all rows. So we know this is what they're looking for. The colon operator can also be used to specify a range. And this is a thing that can be a little bit confusing. So we're going to create volumes equal data. This data, we want to contain the last 2 columns of data. So we want to create volumes. You can also see the size of data in the output pan. Yeah, so data is 4 wide. So 4 columns. We want the last 2 columns. So in order to get all of those, we want all of the rows. So semicolon. We want the last 2 rows. So you can't do like 3, 4. This will create an error. I want you to see it. Position 3 exceeds the boundary arrays. Sometimes the error messages are not as helpful. So if we want 3 and 4, 3 to 4, so the last 2 columns, let's run that section now, and we get the last 2 columns, all rows. We could do that alternatively, another way. If we didn't know how big it was, for instance, end -1 to end. Run section. Okay. So same thing, except we're using the end, so that we're using the second to last and last address for the columns, all rows of data. So that's using things that we've just learned for some other instances. Now they want a variable named P containing the 6th element. So of 6th element of density. So density, 6th element. So this is the information that is at position out of density here, position 6. So the 6th element in density. Here we can also use, so they're going to use the end example. So it's almost like I've done this before. Next task. Task 4. Create a vector named Q containing the 2nd through 5th elements in density. Density 2 through 5. Density 2 through 5. So 2nd through the 5th value. And this is going to work in all indexes, even for loops and all sorts of things. We're going to use this a ton, an absolute ton. So 2nd to 5th entities in density, or elements in density. Technically they're elements, they're not actually entities. A whole bunch of reasons why. So 2nd, 3rd, 4th, 5th, and we match up nicely there. So we have another one that we can take a look at here. Indices can also be non-consecutive numbers. To extract the 1st, 3rd, and 6th elements of density, you would say R equal, to assign it to a new variable, because you have to store the output somewhere. That's not entirely true. It is useful if you store the data to a variable, you can just output the data full stop. There are certain circumstances where that is all you need to do, is just output the data. So you could just say, instead of r equals, you could just say density and then the address that you need the information from. So I'll show you that that works in order to understand it. But if you're going to do that, you actually need to index it this way and give it the odd evens and odds. So 1, 3, 6 as an array. So I'll show you that it works the one way, and then I'll show you that it works the other way. It'll give you, this might be an invalid syntax, and it yes, it can be. So 1, 3, 6, it really does still want yeah, I was using brackets instead of parentheses. That's interesting. So it's supposed to use brackets. One, 3, 6. Yeah, in brackets, you can make that work. Yeah, you have to use a space because, yeah, that's right. You have to use a space. For the index, no, there's one other trick for doing an array example. Yeah, let me look real quick and troubleshoot it, because it's not, we're not treating it as a function. There's actually another thing that's got to happen there. Because there's some other functions that you can also use to extract data as well. So yeah, let me grab that real quick. All right, so it's using as the index the array of values. You have to use the index inside of the parentheses because reasons. Yeah, just yeah. So this is a thing you might have to do at some point, possibly. This is a little bit less common use case scenario for stuff that I've done in Matlab. It doesn't always necessarily mean a whole lot, but this will at least give you a reasonable starting point. Okay, so we're done with array indexing. So let me step back out. At least I think, no, this is still indexing and modification. So there's one more aspect they want us to get a handle on. Okay. So yeah, reassigning an element. So this is actually a pretty important one. So it's not a repeat of the same one that we did already. We need a vector v2 equal the last column of data. So all rows, last column. Okay, run that section. Okay, last row, all columns. Okay, so we're going to run the whole thing. All right, make sure we've got that showing up correctly. All right, submit this. We need to then change the value, not a number, to 0.5. So we say within V2. So V2 is now our V2 at, and then we give it an index at position. In this case, we're just going to give it position 1. Equal means reassign it to this value, 0.5. And then we're going to suppress that output. And we're going to, underneath that, print V2 to the command window, which is this thing. And we've changed not a number to 0.5. Okay, so now we can go back and suppress this output and keep going with our function. Or keep going with our script, rather. So we also want to change the not a number in the data array, data at 1, and reassign it to be 0.5. Let's press that output, print data so that we can evaluate whether or not it did it correctly. 0.5 is now the new number. Okay, so we can suppress that output and keep moving. So their extra practice here is combining index with an assignment to change an array. So this stores the value at x in the second element as the first element. So this is a reassignment from a further indexed value. There's actually a lot of instances where you're going to do this kind of a function because you're going to need to update a data set after you've done something. So we're going to change the first column of data into the second column. So first, all rows, first column. All rows, first column. Reassign that to be all rows, second column of data. So we're going to change the first column into the second column of data. So we're going to now run this and it'll show the first column is gone. The second column is there. The array is still the same size, or the matrix rather is still the same size. You'll sometimes hear me slip and say array and matrix interchangeably. They're not really. An array is a special case of a matrix. But now we have the two columns being the same. This kind of moving your data and replacing it with new data or something and keeping a library of it to be able to do stuff later. This actually has a lot of uses for many things. So then we get into array calculations and other things that this really does a great job walking you through the way that these actually function. So the key is, especially with some of these particulars, I'll go to the plotting because there's a lot of confusion that can happen in that. So the array calculations, there are some points of confusion that can happen in those. Plots and data importing, those are reasonably straightforward. Logic arrays we've started to do some of in in Arduino, but it's a little different in MATLAB. And MATLAB has some kind of neat features to be able to make these work a little bit better. So we have our sample data file. It's loading the data file and it's creating a vector v1 out of that data set that is all rows, third column. Okay, great. Relational operators such as greater than, less than, comparable to, and almost are similar. So this is equal, and this is basically, are they approximately equal? Are they close? That'll report a Boolean value, so 1 or 0. We need to test if pi is less than 4 using the relational operator. So pi is a little bit different. Assign the output to a variable named x. X is and for these logical operators, pi, because it's a function, I'm trying to remember offhand if pi requires I seem to recall pi is actually a function, and you can define it to a certain number of decimal places. The default is sufficient for what we're trying to do here, but we're going to say that is less than 4. So we're going to store a true or false, but I want to run this to see if my syntax is correct. Yes, it is. So pi is a function. You can leave it empty because it's a void. You can always right click and do help on pi. I am always going to push you to go to the MATLAB help. This used to be a lot harder to use than it is because of reasons, but you can use it, I think, with or without. That's right. You can use it without parentheses. You can use it with parentheses just to remind yourself that you're not redefining it. But it gives you a value, and it's this is our default. So a bunch of things that can help us. So you use this in place of pi in order to make things work. There's other things that you'll use the help for, but I am always going to recommend you go to the MATLAB help because it's probably going to save your life. Like, really, no kidding. Yeah, it's a really big deal. So is pi less than 4 logical? Yes. Good. So now we need, you can compare an array to a single scalar value using relational operators. Y is what we're storing. Test the vector v1. V1 for elements that are less than 4. And this is the easiest way to do this is going to be, I think you can do all rows, but Y is going to end up with Y should end up being an array answer, and that part should be correct. So V all rows less than 4. So it outputs a logical array for Y. I wanted to verify that it was pulling V1 first correctly. So it outputs a logical array for all elements less than 4, and the third and fourth elements are less than 4. So we don't see the data array up here because we have it suppressed as output. Okay, so we know that's correct. And we move on. Using a logical array as an index so that it can extract elements that have certain properties. So if you're trying to dig through a data set and say, okay, did all of these people actually die of COVID, or did they all get run over by semi trucks and then also have COVID at the point they died? If you're trying to extract something like that out of a data set, this is the kind of approach that you would be using for that. So in our case, we're going to create a variable z. Z is going to be what we're storing to z is all of the elements of v1 that are less than 4. So v1, and we're going to give the index of v1 less than 4. So that can be used as an index. And now we look at what z is output. So the two values, if we unsuppress out of this and run that section, we can see our two middle values are correct. So they have that hidden intentionally so that you guys can't just manually input it or something silly like that. So we know that's correct. And you can use logical indexing for two different arrays. So we want to create a variable A that contains the elements of sample corresponding to where v1 is less than 4. So v1 less than 4. But this is going to be our index. This is going to be our index. So we're going to create a variable A that has elements of sample corresponding to where v1 is less than 4. So again, here we've defined sample so it knows what the elements are. They're looking at, based on this data file, where these two variables belong. We need to know what's in the original first column, all rows. We want to know what corresponds with that first column. So you're tracking times and dates. Again, the example of the example that I gave is not to be crass. It's to be simply clear on what you're trying to access. Maybe it's, okay, well, what were the names, or what was the dates, what were the times, etc., that you might have in the first column that correspond with these particular data events that you were hunting for. And that's how you extract that information out of it. So we know that to be correct. So the logical indexing is another way to, there's another way to do this, and you're looking to replace all values equal 999. Maybe there's a particular thing that happens in your data system, your data management system, something that creates this particular circumstance. So you want to create the you want to take this and fill out the way that this operates. So let's do modify v1. So v1 so the values are v1 if the values are comparable to any values, okay, any values less than 4, v1 less than 4, we're going to reassign those as 0. So now we still have the rest of v1, but the two values of interest are now reset to 0. So now nobody died of non-COVID reasons in our data set there. Excellent. Exactly what we should see in the data set. Okay. You can also combine some other logical comparators in this process. The and or are extremely powerful. This is some really good practice to be able to put this together. So try extracting values in sample that are between 10 and 20. So you can say, I'm going to say again, R to store it to a variable because reasons. Sample with an index. And I want to say in sample the values that are between 10 and 20. So if they are sample greater than 10 and sample less than 20. So between 10 and 20, that's also very, 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 very specific language. We're not saying less than or equal to, greater than or equal to, because they want to exclude the actual values of 10 and 20. They only want to know the values between 10 and 20, meaning values from 11 to 19. So it's very specific language, has to be followed very specifically. So this then is the values of these things. So 18 and 19 are the two that are between 10 and 20. Another way you could express that is if they are this one, yeah, you can really you can do greater than 10 or less than 20. Problem with or is you have values that are less than 20, which is most of them, or greater than 10, which is all of them. So or isn't a good operator for this circumstance. You could rearrange it to be, but it's going to be more headache than it's worth. Just use and for this particular scenario. All right. So logical arrays are key to all sorts of operations within MATLAB. So there's some additional levels of programming and things. So the core of what we would need you guys to do this week really is to finish out all of the MATLAB on-ramp, download your certificate, and so from here, share your certificate in progress, upload that to the assignment, and that way we know you guys are at least functional in a basic sense in MATLAB. So that's going to be the main focus of this week, and we'll reconvene next week with some more details and get a little bit more into some more detailed programming. And I'll probably use a couple of their elements for some of the core basics to be able to help give some structure to these in a way that's going to make sense and make these applications a little bit more clear. So I'll try and keep an eye out for messages and all the things. In the meantime, continue trying to get these all filled out, because this will really help get clarity on how this stuff works, how MATLAB works. It'll really help get you up to speed without having to take an entire semester course to get to be functional in MATLAB like we used to have to do back in the day. So thanks for joining, and we'll see you in the next one.